Hey guys, welcome back to my channel. Today we are going to solve a question from the GFG weekly coding context. Uh, Guys, this read the question. Super palindrome. You are given a two integers L and R. We have to count how many numbers super palindromes are there in the range L and R both inclusive. A number is super palindrome if it is a palindrome in its decimal representation. uh, Guys, here it is a so here L and R. So guys, what is saying is, uh, for example, L is equal to 1, R is equal to 10. We have to find super palindrome numbers. A super palindrome, it should follow two conditions. Condition one is uh, condition one is uh, it should be a perfect square, and it should be a palindrome. Okay, it should follow two condition. Guys, this is a easy question, but main twist in the problem is, we can check easily whether it is a square, perfect square or not. But we can check easily it should be a palindrome or not. uh, to check it is a to check whether the number is a perfect square or not. We can check if I into I is equal to some t. If you want to check a number t, if I into I is equal to t, then I is a square root of t. So guys, this is a perfect palindrome. So guys, what I am saying is, we can check the palindrome also. We check the perfect square like this, and by we can check palindrome, we have to reverse the number. How we reverse the number? While if x is not equal to 0, we have to store some y is a number. Y is equal to y into 10 plus x percentage, x percentage 10, x percentage 10. Here this is 10. X is equal to x by 10. So x by 10. So we have to store this x previous in some number z. If this is in this process, it going to reverse. If reverse number is equal to what number we get after doing this procedure, y. So y, then we can say, but this is a palindrome. We have to, if it is follow these two conditions, then we have to increase our answer. But here the main task in the question is, see guys, here if I do this problem, what logic just now, what logic I just now. So guys, here for int both are inclusive, right? Int I is equal to int I less than I less than or equal to r I plus plus. So guys, here uh, we have to check whether I is a, first we have to check whether I is a perfect square or not. So I am taking this number temp one number. So I am square root of sqrt of I if temp1 into temp1 is equal to I. That means it is a perfect square, no doubt in that. And here one more thing we have to do is, I am taking some variable x. Int x is equal to I into sum is equal to 0, while x is not equal, I am reversing that number. I am reversing that number while x is not equal to 0. Sum is equal to sum into sum is equal to sum into 10 and x percentage 10. Okay, and x is equal to x divided by 10. This is we are doing the reverse number. You try take one example. We do the reverse of a number by in this procedure. So guys, here we get the final number in reversed number in sum, or you can write here reverse reverse. Okay, now reverse reverse. So guys, here if reverse is equal to reverse is equal to temp 1, then I am incrementing our answer. Then I am incrementing our answer. I am returning that. But what happened is, if we check this, here we got the wrong answer because remp 1 here where we use remp here it is temp 1. Okay, here while spelling we did wrong. Here we got wrong answer. Why? Because square root of I answer plus plus, if reverse is equal to reverse into 10, x is equal to x by 10. uh, Here we did wrong where reverse x is not equal to 0. We have to check that number is palindrome x is equal to is temp 1. If temp 1 is equal to int reverse is equal to reverse into 10 x percentage 10. Here somewhere we did wrong. uh, Reverse temp 1. Sorry guys, here it is we have to check it to I right, we are checking reversed number is equal to I. So it is temp 1 is a square. Now we got correct answer, but here what happened is we get TLE. Why? Because here we got TLE. Why? Because here see the check the constants. Constants are up to 10 power 9. So a machine can accept up to 10 power 9 only. Up to 10 power 8, sorry, up to 10 power 8, it is not accept more than 10 power 9. Here we use we are traversing from, if for suppose if some test case is like this, 1 to 10 power 9, 1 to 10 power 9. So guys, here it is increasing 10 power 8. Okay, now guys, how I optimize this code is, it is very simple. So uh, here how I am optimizing this is, I am traversing from the square root. L is equal to sqrt of L am, and R is equal to I am checking in between squares R. Okay. Now guys, here what we have to do is, here this is a I into I. Okay. Now temp 1, temp 1, it is square, right? It is square, and temp 1 should lies between, temp 1 is greater than, uh, here we have to store uh, uh, greater than L into L. And why am you can, instead of this, you can previous range, right? It is some L1 is equal to L, and into R1 is equal to R. Okay. R1 is equal to R is greater than L1, and temp 1 is less than or equal to R. Temp 1 is less than or equal to R. Now guys, uh, here here these are all square numbers, right? So here what we have to store is, uh, here some little bit I am changing here algorithm. We have to check that number. Here temp 1 is that number. So here instead of that we have to put here temp 1. uh, Here we are reversing that number, we are storing that into X, and here reversed number should be, here X is going to be temp 1, X is going to be 0, X is become 0, right? So X is become 0. Now I am submitting this code. I hope this is correct. uh, I is not declared. uh, Here we forgot here semicolon. Here we got correct answer. Now I am submitting this. Yeah, it satisfies all test cases. What I did is, I am for suppose uh, what I did is, now if he asked us to 100 to 10,000. So what I am where I am checking in this number, we have to check square numbers and palindrome numbers. Palindrome number. Okay. Square numbers and palindrome number. So uh, so guys, here what I am doing is, I am iterating from the square root of both numbers. Okay. Square root of both numbers means I am traversing from 10 to 100, and I am checking whether their square, 10 square is lies between this, and level square is lies between this. And after so 100, right? I am checking whether it's 100 is palindrome or not. I am squaring this level. After 10 I got level, right? 121, whether it is lies between this two and or not. I am reversing that number. I am checking them. I am checking two things here, whether it is lies between that square is lies between these two or not, and that should be a palindrome. This is our question. Okay guys, if you have any doubts in the question, please ask in comments. Please ask in comments. This here this L1 R1 I stored because these are previous values, so I am storing those values. Now this is the same part. I am just reversing the number, and I am multiplying with I into I. I am doing the square. I am checking whether it is lies between previous intervals means what intervals he given. Why I am not taking L and R? Because I did square, right? Square root of that. So I am taking the reverse of that number. If the reverse of the number is equal to current number, then I am checking, I am incrementing that answer. Okay guys, if you have any doubts, please ask me in the comments, and thank you.